Okay, so in today's session, we'll be discussing about a distribution board. So we already know what is distribution board and what is the purpose of that. So distribution boards are used to distribute the power to different sections or different appliances. Okay, so mainly when you take a distribution board, we'll be having two types. First one is called single phase DBs and three phase DBs. Single phase DBs, obviously it will be used in single phase connection, and three phase DB will be used in three phase connections. Okay, and in single phase we only have one type of DB, that is called SPNDB, that is called single phase single pole neutral DB. Okay, then we have three phase connection. In three phase we have three classification, that is TPNDB, triple pole neutral, vertical DB, and 7-segment DB. These are the three classifications. Again, sub classification for what? The three phase DB. Okay, and what's the difference between these? Okay, so in single phase DB, we'll be having incoming will be single phase and outgoing will be, again, obviously it will be single phase itself. Okay, so single phase incoming and single phase outgoing. Okay, in three phase, especially in TP and DB, our incoming load will be three phase. Okay, so obviously for all three phase connection, incoming will be three phase itself and the outgoing will be single phase. Okay, so three phase incoming and single phase outgoings. In vertical DB, it will be again incoming will be three phase and outgoing will be also three phase connection. 7-segment, again incoming will be three phase or incoming, outgoing will be single phase outgoings. So that's the difference between these three. Okay, so you can see TP and DBs mostly will be used in commercial spaces and the residential spaces here. And vertical DB, you can see that's three phase incoming and three phase outgoing. So where we have a lot of three phase equipments, connections, motors, pumps. So for those connections, we'll be using vertical DB. Again, for residential also you can use the vertical DB also, okay, but will be costly. Okay. Then finally we have 7-segment, similar as our TP itself, three phase incoming and single phase outgoing. So these are the main outline of this distribution boards here. Okay, so let's see one by one is. So you can start with the SPN here. So when you come to the single phase neutral DB, a single pole neutral DB, we'll be having obviously we'll be having the main service line. Okay, so we'll be having three phase and one neutral. So if it's a single phase, you'll take the connection from one phase and one neutral. Okay, so this main incomer will be connected to a in this case, in this schematic is only shown double pole MCB, but actually the first connection will be a fuse. The phase power will be connected to a fuse, then to a energy meter to take the billing for the billing purpose, to take the reading, how much energy you're consuming. For those purpose, you'll be using energy meter. Then we'll be having the double pole MCB. Okay, for a single phase connection, the main incomer will be a double pole MCB with a double pole RCCB also. And from here, this is the phase connection. Okay. Okay. So the phase will be connected to single pole MCBs. Okay. So you can see that right now, 1, 2, 3, 4. 4 outgoings are taken here. Okay, so single phase incoming and single phase outgoing. So if we are using a SPMCB, means it's a single phase outgoing itself. Okay. And the neutral will be connected to a common neutral link, and we'll be having the ground connection as well. So this is how the SP and DB connections will be. Okay, so in SP and DB, maximum outgoings you can take is 16. Okay, like this. So right now 1, 2, 3, 4. Like this, maximum 16, 1, 6 outgoings you can, single phase outgoings you can take from one single SP and DB. Okay, so if it's more means, suppose if we have 20 connection means you have to what, split that. That means you have to take 2 DBs. 10 connection in 1 DB, 10 connection in what? In the second dB. So that's how you take the connection. Okay. So yeah, this is how it will be. Here it is shown. So you'll have the service drop. From there, the phase connection will be connected to the fuse line. Then you'll connect to the energy meter. From the energy meter, it will be going to a double pole MCB, and then coming to the double pole RCCB. From the phase will be connected to single pole MCB. So this each single pole MCB will be distributed. One will be for the hall, for the kitchen, bedroom one, or if it's power load, we'll be having AC, geyser. So, and the maximum rating which you can take from one SPMCB will be single pole MCB is what? Maximum 10 points. That means 10 connections you can take from one single MCB or 800 watts. That's the maximum you can take from one SPMCB. Okay. No, already these things we already mentioned. It is used in what? Up to 5 kilowatt. That means up to 5 kilowatt means a single phase load. Maximum outgoings you can take is 16 outgoings. Okay. And again, it's not necessary what also. Okay. So yeah, that's our first dB, SPM, dB. Okay. So this is the only dB in single phase connection. So next we can move to the three phase. Okay, so this one clear. Next is TP and dB, that is triple pole neutral dB. So it's a three-phase connection. So you can see that the first main incomer will be a four-pole MC because we'll be having four line, three phase and one neutral. Okay, so this is the main incomer, four-pole MCB. From the four-pole MCB, it will be got to a four-pole RCCB. From here, the outgoings will be single phase. As you can see that this is the R phase outgoing, Y phase outgoing, and B phase outgoing. So the phase outgoings are single phase. R phase will be separate, Y phase will be separate, and B phase will be separate. That's what it's called. Incoming is three phase and outgoing is single phase. Okay. So you can notice one thing. This is the R phase outgoing. And in the R phase outgoing, I have taken three single pole MCB. And that means three outgoings I have taken from one phase. Similarly, you can take up to 14 outgoings. 14 outgoings from one phase. R phase I can take 14 outgoings, Y phase I can take 14, and B phase I can take 14. So that means total I can take 14 by 3 outgoings for a single TPN MCB, TPN DB. Okay. And this is how the DB look like. So here you can see that this is the main incomer, our 4-pole MCB. Okay. Next we have 4-pole RCCB. From the 4-pole RCCB, this one is our R phase outgoing. So in this R phase outgoing, you can take, see that 1, 2, 3, 4, 5, 6. 6 outgoings are taken from one single phase. And this one is our Y phase outgoing, and this one is our B phase outgoing, and the black one is our neutral link. So that's our connection. And in three-phase connection, up to 50 kVA load, you can use what? TPN DB. Okay, clear. And the next one is vertical DB. Okay, so this is the only DB in three-phase which we have what? Both three-phase incoming and three-phase outgoing. Okay, so here there is the TP MCA triple pole MCB is used for the main incomer side. So the three phase is connected here. Okay, and here we have one more additional element that's called phase splitter. So phase splitter is actually a copper bar, like our normal bus bar. Okay, so this is the R phase outgoing, Y and B. So this outgoing will be connected to a phase splitter. From here, we will take the connection to our three-phase equipment. Okay, so here you can see that from R phase I have taken one node connection, from Y phase I have taken one connection, and then from the B phase I have taken one connection. To this again we have used one more triple pole MCB. Okay, so from this MCB outgoing is also what? RYB. That means three-phase incoming and three-phase outgoing. Okay, so from the same DB we can also take single phase connection also. Okay, how means you can, instead of this triple pole MCB, you can add one SPMCB. Okay, so if you take one single pole MCB, I can take connection from the R phase here. Again, if you take one more single phase MCB, you can take connection from Y phase. Then again, here you can take one more single pole MCB. Then I'll take a connection from the B phase. So like that, you can take both single phase as well as the three phase outgoing. So mostly you'll be connected to what? Yeah, the purpose of the vertical DB is to use in the three-phase loads. Okay, so both can be used. Okay, so that's why I mentioned earlier. You can use single vertical DB in the residential space also, but the cost will be higher because this phase splitter is a copper bar. So from the copper bar, we're taking the connection to each MCB incomers. Okay, and this is how the DB look like. Okay, so here you can see this is the three-phase incoming. R phase, Y phase. Okay, so here we cannot say R phase and Y phase because this RYB color code actually we are using in India. So in other countries they'll be using different color codes. Okay, so here this is the three-phase incoming. So brown, black, and gray. These are the color code they are using. And blue one is a neutral. See, this is the neutral. Okay, and the yellow and green is given for the earthing. Okay, so here this is the three-pole MCB. Okay, so this three-pole MCB is connected to a phase splitter. So this is the R, Y, and B phase splitter. Okay, so that phase splitter you cannot see here because it will be behind this protection. Okay, and from here, R phase one connection, or Y phase one connection, then for the B phase one connection. So this one is again one more triple pole MCB here. Okay, so from here again 1, 2, 3, 4. So 4 outgoings are taken from this single vertical DB. Similarly, you can also take what? 14 by 3 outgoings. That means from one phase you can take 14 outgoings. R phase 14, Y phase 14, and B phase again 14 outgoings you can take. So that's our vertical DB. Clear? Then finally we have 7-segment DB. So 7-segment DB is actually similar like our TP and DB itself because it's having a three-phase incoming and single-phase outgoing, right? But the major difference is why it is called 7-segment means you can see 1, 2, 3, 4, 5, 6, 7. So that's why it's called 7-segment DB. Okay, so let's compare with the TPN here. So here you can see the 4-pole RCB. From the 4-pole RCB, it is directly going to what? Single pole MCBs. Okay, so let's consider if you have a fault in the B phase. This is the B phase. So if you have a fault in B phase, this fault will be reflected onto the RCCB, right? That's the purpose of RCCB. RCCB will check both incoming and outgoing current. If there is any leakage or any fault in the extra current commuter system, it will goes to what? Trip condition. So once this goes to trip condition, what will happen is other two phases will be what? Cut down. This is taken from a single four-pole RCCB. So if it goes to trip condition, all the system will be what? Shut down. But we have only fault in the B phase only. This is a problem for the TP and DB here. On the other hand, if you go to our 7-segment DB, here you can see that there is individual double pole MCBs are what given for each phase outgoing. For R phase, I have one double pole, Y phase again one, and for B phase also I have what? One double pole MCB. Like the same situation, if any fault happens in the B phase, this double pole MCB will go to trip condition. Okay, other two phases will be unaffected. So these two phases will be running as usual. This one will be what? Shut down. Also, for each phase, there are actually common neutral link is connected. So in the TPN, there is a common neutral link. Okay, but here, for each phase, we have what? Neutral link is there. And for each phase is grounded separately. So you can see that this one is more safer than the TP and DB. Okay, so that's the difference between 7-segment and our TP and DB. Okay, obviously it will be costly, but this one is most in usually again commercial space also you can use that. And the spaces where we need proper power distribution. Okay, so those spaces we can use the 7-segment DB. Okay, and this is how the DB look like. So as we mentioned, this one will be our 4-pole MCB, our main incomer. Then here you can see that this is the R phase outgoing. Okay, so it is going all the way to the top, and this is the R phase. Okay, and here this one is our main double pole MCB for the R phase. This is the double pole MCB for Y and double pole MCB for the P phase. Okay, and similar as all other our 3-phase DBs, this one also have what? 14/3 outgoing. That means R phase again take 14 outgoing, Y phase again 14, and B phase again 14. So that's the maximum outgoings you can take from one 7-segment DB. Okay. So yeah, that's type of distribution boards. I hope the session is okay. Any doubts? Okay, so moving on to the next one. That is panels and subpanels. Okay, so normally if you compare your house, you'll be having a distribution board. From the distribution board only, you are getting the power to what? All the spaces or all to all the appliances, right? But when you consider commercial space, it's not like that. We'll be having panels. From the panels, we'll be having again subpanels will be there. From the subpanels, the power will be distributed to the distribution board. So actually, there is a lot of panels will be coming before the distribution board. Okay, so before explaining this one, I'd like to explain the flow diagram. Okay, so when you take a panel board or a commercial building which is having a 3-phase connection, first you will get a 11 kV supply from the electricity board. Okay, so if your connector load is more than 100 kV, you don't get direct supply from the EB. You will get 11 kV supply. That 11 kV supply we have to step down, then we have to distribute in our building, right? So here you will have 11 kV supply from the EB side. That connection first will go to the unit called LBS. LBS means load break switch. Okay, so load break switch, the purpose of the LBS is to what? To isolate the building and the EB. Okay, so the purpose is only on or off. So there is no protection you'll get from the LBS side, just like our normal switch, on or off purpose. That's it. Okay. After LBS, next unit is called SFU, that is called switch fuse unit. Again, it's a fuse. It's also called high rupturing capacity fuse. Okay. Then we have CT and PT. Again, this one is actually the same purpose as the fuse. Okay, to give the protection. Then the CT and PT, the current transformer and the protection transformer, both can be used. Okay. Then the circuit breaker. Okay. So the circuit breaker is placed in the main incomer side. So after circuit breaker we have the transformer. Okay. So before, if you have one circuit breaker, means this is the ST side circuit breaker. This entire section is called ST side or high tension side, because the supply voltage over here is 11 kV. Right. So here the circuit breaker will be the vacuum circuit breaker, VCB. Okay. Then we have the transformer. Transformer, what is the purpose of transformer? It's a distribution transformer, or we call it step down transformer. The transformer will step down the 11 kV supply voltage to 440 watt. Okay, so the ST is converted to what? LT, low tension. Clear? And the current transformer and protection can be both. It can be measuring, it can be protection type. If it is measuring, means you will connect a ammeter or a voltmeter. If you want to measure current, it will be measuring type, current transformer, and ammeter will be connected. So you'll get the reading. Okay. If it is measuring type, potential transformer means you'll measure voltage. So a voltmeter will be connected. Okay. If it is protection type, you have protection type current transformer and protection type potential transformer. So if you want to get protection from the current, you will use current transformer. If you want to get protection from the voltage, you'll use potential transformer. Okay. So this entire side, or this entire unit will be called HT panel or USS. USS means unitized substation. So this will be a single panel. Okay. So that panel is this one. This one is our HT panel. Okay. So over here you can see this one is our LBS side. Okay. And our switch fuse unit, CPU unit. And this one is our transformer. See, this is a transformer. This is a dry type transformer, or we call it cast resin transformer. Okay. And this one is our circuit breaker. Okay, so normally you cannot see this one, normally it will be closed, so you can see a single panel it is, but actually this is the inside of the panel. Okay. After that, this will be coming to the next circuit breaker, next unit, that is called MSP. MSP means a main switchboard panel. Okay, so after stepping down, the first panel will be called the MSB. It's also called MDB also. Okay, MDB means main distribution board. So from here only we are distributing the power to different panels. Okay, and the panel in the MSP panel, the main incomer is a circuit breaker. This circuit breaker will be ACB or MCCB. Okay, so ACB or MCCB, how to choose means if the load is above 800 ampere, you will go for ACB. If it is less than 800 ampere, you can go for what? MCCB as well. But if you want more protection, most commonly you'll be using what? Air circuit breaker itself. Okay. Then after ACB, the next one is bus bar. So bus bar is used to what? Split the connection. Okay. And how many number of connections you can take from one MSP? Okay, so the maximum outgoing max max outgoings you can take from one MSB is 8. Okay, 8 outgoings or 3000 ampere. That's the rating. Okay, so you can see that right now 1, 2, 3 connections taken. Like that, I can take what 5 more connections from a single MSP. Okay, and one thing to note is some connections we have to take directly from the MSP itself. So for examples, it's given here like fire pump panel, common panel, also APFC panel. APFC means automatic power factor connection panel. I'll come to that in a moment. APFC panel. Then usually lift will be given in common panel because it's a common area connection. Okay. Even if it's not, you have to connect to what? Our lift panel also. Okay. Then chiller. So like this heavy load connections will be taken directly from the MSP itself. Okay. If we have more numbers, okay, so if the connection exceed over 8 numbers, that means we have to take what? One more MSP. Or if the load goes above 3000 ampere, you have to go for the second MSP connection also. Okay. But one thing we can do is we can take a intermediate panel. Intermediate panel means if the connections goes beyond 8 outgoings, one more panel we can take that is called SB panel. SB means switchboard panel. Okay. One more thing here we can see that from the common panel, the connection will be given to the common panel. There we have what? A circuit breaker, then the bus bar, then two various motors and DPs. So common area connection include the water supply system, the basement ventilation system, same the lift connections. Okay, and the common area lighting, uh, outdoor lighting. So everything will be in the common panel. Okay, the idea is if it's a apartment or a shopping mall, shops will have individual connections, individual power supply system, individual air conditioning system. But the shopping mall will have what? Some common area like the passage or the gathering space. So these are common for all the people. So those connections will be given in the common area like lift, escalators, all that will be in common area. Okay, or common panel. Then we have fire pump. So fire pump panel obviously it will be pumps. So from the panel we'll have circuit breaker main common will be ACB or MCCB depending upon the load and everything. Then the bus bar. From the bus bar we will distribute the connection to different pumps. And how many number of pumps we have for all the pumps? We'll give the connection. So electric pump, jockey pump, the other pumps we are using in the fire pump side. Okay. Then we were discussing about SB panel. SB panel is the intermediate panel. If the connection goes beyond 8, you will take a SB panel. Okay. So when it comes to SB panel, from SB also we have certain number of outgoings. Okay. So maximum outgoings you can take from one SB is 8 numbers or 1500 ampere. Okay. So this 8 outgoings or 8 numbers means you can take 8 SSBs. Okay. SSB means sub switchboard. Okay. So SB, you can from one SB panel, you can take 8 SSB. From the SSBs, you can take what? The connection for the distribution port. Okay. So here you can see. Again, we will be having one more circuit breaker, then the bus bar. From the bus bar, you can take 8 SSB outgoing. From one SSB, how many dBs we can connect? Okay. So from one SSB, if you have single phase dBs, you can take what? If you have single phase, you can take 12 dB from dBs from one SSB. If it is three phase, you can take 8 dB, 8 dB outgoings. If it is mixed, Mixed means single phase and three phase mixed. Again, you can take what? 8 dBs. Okay. So this is the maximum outgoings you can take from one single SSB. Okay. Then maybe again as a main incomer we'll have again some circuit breaker, then the bus bar, and from this bus bar we'll split the what? The DB connection. So this is how the SLD will be. Singular diagram for how the flow comes from the 11 kV supply till we reach our dBs. Okay. So once again I'll brief this one. We'll have 11 kV supply. The 11 kV supply will be given to the transformer, and the transformer will step down the 11 kV to three-phase connection or to the 440 volt supply. Then after stepping down, the main incomer or the first panel is our MSB panel. That's the main switchboard panel. From the main switchboard panel, you can take maximum 8 outgoings, 1 MSB. Okay. So 1 MSB, maximum 8 outgoings or 3000 ampere. Then in the MSB, the main incomer will be a air circuit breaker or MCCB, depending upon the load. From there, we'll split the connection using a bus bar, and this bus bar will be connected to one, for example, it's given here, one SB panel, one fire pump panel, then common panel, then to APFC, then to lift panel, then to the chiller. So like this, 1, 2, 3, 4, 5, 6 outgoings I have taken from this single MSB. Okay. And if our connection number goes above 8, you can take one intermediate panel. That intermediate panel is called SB panel. That's called switchboard panel. So from one SB, okay, so from one SB panel, you can take again 8 outgoings. Okay, this 8 outgoings, or specifically you can say 8 SSBs can be connected from one SB. If you take one more SB panel means again, if you take one more SB2, again one more SSB is taken. That means again you can take what? 8 more SSBs. Okay. So again in one SSB, okay, SB you can take 8 SSB. In one SSB you can take what? 12 dB connection. If it is single phase, if it is three phase, you can take 8 dBs. Mixer also you can take what? 8 dBs. So
Sir,
that's
sorry to one small. From SB, directly we cannot connect to DB, no, so it should go through SSB only.
it's not necessary. If you have only 8 dB connection, you can take directly from SB itself.
Directly from SB, okay, okay.
Yeah, that's
Yes,
okay. But if you have more numbers, you'll have to split that. That's it. Normally, when you take the connection, if you consider a building,
okay.
for one floor, you'll have one SB. Second floor, you'll have one more SB. So floor-wise distribution will be there.
Got it. So different SB.
Again, from the SB, you can take again multiple SSB. So when the number of connections is more, then only you have to what? Take more SSB connections.
Oh, okay. But from one MSB, only one SB.
No, that's what I mentioned. In one MSB, you can take one more SB also. That's what written SB2 again you can take.
Okay.
Again, you can take again more SSB connection you can take from what?
How many maximums are like that?
Maximum 8.
8 SB.
8 outgoings you can take. It can be SB connection or fire pump connection. Any connections you can take.
Okay. Got it, sir. Okay.
Even if your building have only 8 SB, 8 panels, you can take directly from the MSB itself. No problem.
Directly from MSB, we can take the 8
You can take.
distribution.
If you have only 8 SSB means from MSB you can take 8 SSB connection. That's it.
Got it.
Okay, so clear. Any doubts? I hope you got an idea about how these connectors are coming to our DB. Okay, so our first topic was DB. So actually into the DB, before reaching DB, we have a lot of connections. That's it.
Clear.
Okay, now, so as Steve already discussed, okay, so this one is our MSB panel. That's our main switchboard panel. So as you can see here, this is the main incomer air circuit breaker is ACB written here. That means it's a air circuit breaker and the rating is 1000 ampere. Okay. So from the ACB, you will be connecting to the bus bar chamber. This is the bus bar chamber. Okay. So how it will look like means this is how it will look like. So this is the panel. This is the main incomer ACB here. And this is the bus bar chamber. And from the ACB outgoing, R phase will be connected to the one bus bar, Y phase will be connected to Y bus bar, and B phase to the next bus bar, and to the neutral to the next one. Okay. And from this common bus bar, we will take the outgoings. Okay. So in this example, 4 outgoings are taken here. So not 4, 3. 1 to SP, and second to the APFC, and third to the fire pump panel. Okay. So all these connections are taken from this common bus bar itself. So again here, R phase outgoing is taken, Y phase is taken here, B phase, then neutral. Then here the main incomer is given a MCCB. Okay. So from this MCB, this will be going to the fire pumps, this will be going to the APFC, and this will be going to the SB connection. Okay, so that's how the connection will be. Okay, and here I think two outgoings are taken from this one MSP. A 320 ampere MCCB is considered here, and it is written. Yeah, here you can see from this MSP, two SSB connections are taken, SSB1 and SSB2. So only two outgoings are taken from this one single MSP panel. So it's not necessary to take what always an SB. You can also take what SSB connection also from the MSP as well. Okay, and here these are the pilot lights. You can see R phase, Y phase, and B phase. So if there is no supply in B phase, or in order to indicate that, you'll have 3 pilot light, and below that ammeters are given to check the current rating for R phase, Y phase, and B phase. 3 ammeters are given here, and this one is a voltmeter given to check the voltage between each phase. So you can have a used to what switch the phase. You can check the voltage between R and Y phase, Y and B, B and R. So you can switch the lines as well. Okay, so that's our MSP panel here. Okay,
Normally, what range it will be there, sir? Between R and Y, like in this case, this is
450.
MS 450, no? Yeah,
Yeah,
three
450 is
phase.
the
It will be
line
three.
three phase. The line voltage will be between phase. It will be 450. Between phase and neutral, it will be 230.
Okay, between phase and neutral, as usual, like single phase 230.
230.
Got it.
Okay. Now, then next after MSB, the next connection will be going to the SB panel. That's called switchboard panel. As we mentioned before, you can take maximum 8 outgoings. Maximum current rate will be 1500 amperes. So you can see that right now from one SB, SSB1, SSB2, SSB3, 4, 5, 6, 7, 8, like that. Multiple SSBs you can maximum 8 SSB connection you can take from one single SB. Okay. So SB is taken whenever we have what more number of connections is more in MSB. Okay. And this is how the connection will be. Same way. One more thing I forgot to mention is here you can see that isolator is shown here. Again, this case you can see a MCCB, a circuit breaker is shown here. The difference between MCCB or circuit breaker and isolator is isolator there is no protection. Just to isolate the unit. For that purpose only we are using. And but why we are using isolator means here you can see that here we have one circuit breaker. Again in the same line I have what? One more circuit breaker used. Okay. So if there is any fault, if there is any fault happens in SSB1 means this MCB will go to condition. We don't have to cut the main incoming supply, or we don't have to use what? 2 circuit breakers in a single row. So if anything happens in SSB1, this will go to trip condition. In SSB2, this will go to what? Trip condition. Okay, so we don't have to use what one more circuit breaker in the main line. So an isolator is enough because we already have what again one more circuit breaker in what our main incomer as well. So we don't have to use a line of circuit breakers. We can also use, again, it's optional, not necessary. We can use isolators as well. Okay. So here in SB panel, incomer is used a isolator. Here again, three-phase incoming. The phase incoming is connected to what? Busbar chamber. From the busbar chamber, each phase outgoings are given to a 4-pole MCCB. From the 4-pole MCCB again, you can take what? Yeah, SSB1, SSB2, SSB3. 5 SSB outgoings are taken from this particular SB panel. Okay. And this MCCB will change depending upon load. If the load is lower means you can also use what? MCB also. Okay. Yeah. And this one is our SSB panel. SSB panel, again, from SSB, we are taking the DB connection. Okay, so maximum DB connection you can take from one SSB is 12 if it is single phase, 3-phase it is 8, and mixed load, so it is 8. And the maximum current rating will be 800 ampere. And we can also distribute floor wise also. In one floor, you can have one SSB. So from this SSB, you can take the all connection from that floor. So you can see that this is the connection to the 1 dB, second dB, third. Again, 2 spares are added. In future, if you are running any more connection, you can what? Connect into the spare part. Okay. And this is our main isolator. Okay. This isolator is for each dBs or each flows maybe. Okay. And yeah, this is how the SSB connection will be to each. So here you can see that dB bar GF bar S1. So this one represent again, first of all, we have one isolator, 3-phase incoming and neutral connected to a bus bar chamber. From there, we have taken to dB1, dB2, dB3, dB4, like that we have distributed. And this represents distribution board. This will be the floor name. And this will be, suppose if it's an apartment, it will be apartment number A, B, C, D, like that will be given. If it is shop means you can see S1, shop 1, shop 2, shop 3, like the names you can give. Okay. And in the main income side, you can see fuse, again, it will be given, plus energy meter. So if we have backup system, you'll have what? Changeover system as well. Changeover we'll discuss in another class. So just understand that you can have changeover systems as well in the main income also. Okay. Changeover is used to, if there is no power supply, we have to switch to the diesel generator side. So the switching between the transformer and the diesel generator is called a changeover system. Okay. So yeah, these are the three panels: MSB, SB, and SSB, and how the distribution is taken. That's it.
Sir, here it goes from fuse plus energy meter. There is no MCCB here, like
That will be there. Okay, so that
that
will
will
be
be there.
common. Like this one itself. Our same connection like our distribution board. This way. Fuse, energy meter, then the
Okay,
as usual. That's it.
okay.
Then fire pump panel again used in what? Now to give connection for the pumps which are associated to the firefighting system. Okay, so commonly we'll be having a jockey and electric pumps and should be connected directly from the MSP itself. So as I mentioned before, some connections are should or mandatorily we have to take from what? From the MSP itself. And these connections should be given full backup condition, whatever the condition is. Okay, so if there is no power supply, this panel should be working as the normal condition. Okay. A chiller we can exclude depending upon the condition. If it is a commercial base like shopping mall or hospital, those should be given full backup as well. Okay. Then the next one is called APFC panel. APFC means Automatic Power Factor Correction Panel. Okay. So when we discussed about the power, we have discussed three types. That is apparent power, active power, and the reactive power. Okay, so apparent power means the maximum power or the maximum current rating which you'll be getting. Active power means the power which you are consuming. Okay, even if you are getting a maximum power, we don't consume that maximum. We will be consuming a limit. Okay, so that consumable amount is the active power or the true power, we'll say. And reactive power, we mentioned, it's the power which we are considering as loss, right? But actually, it actually not a loss. We can store that reactive power. Okay, so when you turn on a motor in the house, you can see that our light will blink for a second. That is because motors are kind of an inductive load. So whenever we turn on the motor or pump, it will take more starting current. Okay. So if you compare with a commercial space, the commercial space or a building will have what? Lot of inductive load or a lot of pumps and motors will be what? Used in that case. So just imagine what will happen if you turn on that for. So it will affect other systems. So what I'll do is for AC motors or the inductive loads, we will introduce capacitor banks. Now, if you take your ceiling fan, okay, ceiling fan or your pump, it will have a, you can see a capacitor bank. So white color cylindrical thing, that's a capacitor bank. So the purpose of the capacitor bank is to store the reactive power. The power which you are considering as a loss will be stored inside the capacitor bank. Whenever the motors are starting, from the capacitor bank, it will take the necessary starting current. Okay, so that's the purpose of the capacitor bank. So APFC panel means it's the collection of or the combination of capacitor banks. So the reactive power will be stored in the capacitor bank. Whenever we are starting a motor or a pump, from the capacitor bank, we will provide the necessary starting current. So the other systems will be unaffected. So that's the purpose of a APFC panel. Okay. So when you talk about capacitors, we have two types. We have constant capacitor banks are there and variable capacitor banks are there. Constant capacitor bank we are using if a system is working 24/7. For those, we'll give constant capacitor bank. Variable capacitor bank, for example, if you are using a water pumps or a jet fan, these are not working every time. Okay, the load will vary depending upon the usage. Okay, so for those connection, we can use what? Variable capacitor bank. Okay, an example for constant one is transformer. Transformer is also what? It's an example for inductive load. So for transformers, we have to provide a constant capacitor bank. Okay. So this is the panel which we are using to store the reactive power. And here you can see constant TR is written. That means this is the constant capacitor bank provided for the transformer. Then 10 kVAr, 20 kVAr, 30 kVAr. That means each will be given for, suppose this will be for the water pumps. This is for the basement ventilation fans, for the fire pump, for the chiller. So for each inductive load or for each motor loads, we will provide what? A capacitor banks. Okay, so that's what it is called APFC panel, automatic power factor correction panel. Clear? So we'll go in detail about the APFC panel. We have one more topic regarding the selection of the capacitor banks and the selection of APFC panel. So in that we'll discuss in detail. So for now, just understand that this is the purpose. Okay. Then yeah, last panel is the common panel. As we mentioned before, all the common area connections. Example, the water pump connection, booster pumps, STP, sewage treatment plant, lift connection, jet fans, all these things will be what? Connected to the common panel, also called utility panel as well. Okay. And these three connections, like the common panel, APFC panel, and the fire pump panel. So these three should be connected full backup. Even if the power supply is down, with the generator backup system, you should provide what? The full backup for the these three panels mandatorily. Okay, for the chillers also. Okay, so common, fire pump, chiller, Lift is actually included here. Suppose if we have a separate panel for lift, again for that one also we have to give the full backup. Okay. So these are the type of panels and sub panels we'll be using in a commercial spaces. Okay. Clear? Any doubts?